Yo, what is it? Oh, shit. Yo, what is up, guys? Lazy Algorithm here. I try to shorten my name sometimes, like Lazy Algo, because algorithm is just like so long to say. You know what I mean? It's like really long. Algorithm. So that's like 4 syllables. So I'd rather just use Lazy Algo. Even LA, if I'm being crazy. Like LA is fine to me, but obviously LA is a place, so it's just gonna sound weird. So I'm here to talk to you today about data structures and algorithms. I can just imagine the PTSD that people are getting from this video, just because everybody knows data structures and algorithms, or DS and algos, is like a huge thing in the computer science world, especially among students and professionals. So it's like the creme de la creme, that of computer science. So yeah, that's what I'm here to talk to you about today, just data structures. So let's break this down. I'm not here to like really go in depth into anything, so I'm trying to make this video as understandable as possible to everyone, not just people that are really technically sound, but then people that are trying to get into tech and they've just been hearing this buzzword data structures when it comes to like interviews, or when it comes to just education, when things they learn online, they're always seeing data structures. So I'm here to really break down what like a data structure is. I'm not really going to talk about algorithms in this video, just because this video is gonna go on for too long. So yeah, let's break down data structures. So we're gonna begin with data. What is data? Like data, you've heard that word so many times. Data, data, I don't know, tomatoes, whatever you want to call it. It's the essential units, just the building block of everything we do in computer science, basically. What is this data? So data is like a raw unit of like information that really exists in like these kind of forms that can easily be, efficiently be like processed and like transferred from one place to another, like within a computer or like within computers like around the world. So they're like the basic building block of information. So data can exist in so many forms. For example, people who are into web development, like you've heard of the JSON format. That's the JavaScript object notation. So basically what that is just like a form that when you make a call to like an API, for example, your data comes back in like JSON format, which is one of the formats that comes, there are other formats like the XML and like the AJAX format, but then the JSON is a very common one. So yeah, that's what data looks like. It's just like pieces of information that we use, or that can easily be accessed or transferred from one place to another. So now let's talk about a structure. What is a structure? So basically a structure is just like the arrangement and like kind of the organization and relationship between elements of like something complex, right? So basically how different elements of something complex like interact with each other. So yeah, for example, like when you go through or you pass through like construction sites, you see like these large structures that they're building. So basically how those elements interact with each other, that's what like a structure is. So now when you put these two words together, like what is a data structure? So basically data structures has to do with like different ways of kind of like organizing and arranging these units of information in the forms of data, and like the way they're stored in memory, basically. And the memory we're talking about here is RAM. So what is RAM? RAM obviously stands for random access memory, right? So I'm gonna try and like briefly explain what a RAM is in simple terms. So a RAM on the hardware side basically is made up of transistors and capacitors that hold electric charges which kind of like represents data, right? So just think of it as some temporary storage place that a computer has. Whenever a computer is like carrying out like some kind of process, like it has this RAM, so this temporary storage where the computer uses to kind of like process the data. So when we talk about memory, we're not talking about like the SSD, like the permanent storage. Like this is just like a temporary thing. So basically if a computer loses power, the data is gone. It's essentially gone if it's not saved to like the storage disk. So what's the point of the RAM anyway? So basically the RAM is just there to help the computer like process the data faster, because it's not as huge as say like the permanent storage, right? Your SSD. A RAM can be common, like RAM sizes are like 4 gigabytes or 8 gigabytes, or yeah. So basically it allows the computer to process the data faster, because every single, like, all the pieces of data it gets like from somewhere, it's processed in the RAM before like it's then further like taken to like the permanent storage in the form of, say, a database or just a file. So if we're looking at the big picture here, right, data structures can typically be broken down into two. So we have the primitive and the non-primitive like data structures. So when we say primitive data structures, these are like the fundamental building blocks of like data structures. So like, for example, you can think of your integer, booleans, floats, doubles, characters, like, like when you're programming in, say, Python or C++ or JavaScript, and you try to define a variable with the variable name. I mean, not all programming languages, you don't have to specify the data type, but for example, something like C++, where you have to specify like the data type. Say you want to define a variable called like 3, right? So you usually write int 3 equals 3, for example. So that int, basically, the computer recognizes it as a data type. You don't have to define really like tell the computer like what data type 3 is. You define it yourself, right? The computer just recognizes that int keyword, and then it associates like the 3 with it, if that makes sense. So these data types can be broken down into like sub data types. So that's what they call like primitive data types. So when we go to non-primitive, there are kind of like two things that come to mind here. You have the linear and the non-linear data structures, right? So what is a linear data structure in comparison to a non-linear data structure? A linear data structure is a structure where basically the data is stored sequentially in memory. What does that mean? For example, say you have a bookshelf and you have 6 slots on the bookshelf. They're empty slots, and you have 6 books that you just get from, I don't know, a friend, someone, a librarian. You just have 6 books, and you want to like put the books in the shelf, right? You have 6 slots and you put each book in each slot, right? Once you step back from the shelf and look at like the shelf as a whole, right? You have each slot next to each other and each book next to each other, right? So that means like you stored the books sequentially. That's what it means. So if a random stranger, I don't know, someone you don't know, a friend, possibly comes to your home and he's looking for a book on your bookshelf, and you stored those 6 books sequentially, right? What could you tell him? You could just tell him, look for just one book, maybe the book at the beginning, the very first book you put in the first slot. You could tell him to look for it, and if he finds that book, he finds the other 5 books, right? Because it's easy, they're all like sequential. So that's exactly what a linear data structure is. If you have the memory location of the very first piece of data, right, you can find the next like consequential like pieces of data, right? So they're stored linearly, like sequentially. So they're right next to each other. And this data structure it doesn't have to be one dimensional. It can be multi-dimensional, like 2, 3, doesn't matter. But like what just matters is the way it's stored in memory. So examples of this are arrays, lists in Python, linked lists, like these are all linear data structures. So basically that's what a linear data structure is. Now when you come to non-linear data structures, like these are definitely not linear, so they're not like sequential in memory. And like, why would you need a data structure that's not sequential in memory? Like, what are you doing? Like, why would you need one? But I tell you guys, depending on the use case, like these can be very important. For example, say you have a social network like Facebook or say Twitter, for example, and I have a couple of followers, you have a couple of followers, and I follow you, for example. So, okay, maybe Twitter is a bad example. Facebook is the perfect example because it deals with friends, not followers, right? So imagine like I have friends, right? You have friends on Facebook, and it's trying to find like mutual friends between us. Now think of it, that would be very difficult to use a linear data structure to kind of like store our friends with respect to our user profile. For example, like if I have 500 friends and you have 200 friends and we're trying to look for mutual friends between us, you would have to go through basically every single one of my friends and go through every single one of your friends to find which are common, right? But there's actually an easier way to arrange like this data. Imagine I have like, let's say my profile is a node and my friend is a node. You know, everyone's profile is a node, and a node just being like just think of it like a circle or a piece of data, right? And every time I have a friend, there's a connection made between our nodes, right? And let's say, for instance, our mutual friend has a node as well. So he has a connection with you and he has a connection with me, right? So instead, we could just like traverse, you know, we can go through these nodes and these pathways, right? And look at where they meet. Instead of like, you know, I don't have to go through all my friends. The computer doesn't have to go through all your friends. But because of that link that one node has between you and me, we know it's a mutual friend. Does that make sense? So basically, this brings me to the definition of nonlinear data structures, right? They're not like sequentially stored. For example, you can think of your trees. Tree is a nonlinear data structure. It's actually a hierarchical data structure. You can think of a graph. These aren't like contiguous in memory, so to say. So yeah, that's what a nonlinear data structure is. So that's basically the introduction of data structures, like the basic understanding of what they are. And you know, this is a tech channel. I'm going to go deep into like every single data structure as much as I can, just to make it like really understandable for people. So I'm gonna like tackle arrays, I'm gonna tackle linked lists, I'm gonna tackle stacks and queues and graphs and tries and trees, you know, binary trees, binary search trees. I'm gonna tackle everything, guys, so you don't need to worry. But this is just like an intro video I made just to give us an understanding of like what data structures are and why we even use them in the first place, and what use case we have for the different categories of data structures. So yeah, it's one thing to just learn and know, but then it's another thing to like really learn and practice what you learn, and that's the way it sticks, because repetition is key at the end of the day. So yeah, that's what's up. That's what we do here. That's what we do, you know, the Lazy Algo Nation. That's how we learn. So yeah, thank you guys so much for watching this video. Please like, please subscribe, and turn the notification bell on if it's off, because you don't want to miss these videos. You know, this is crunch time for maybe CS students, or if you're just trying to get into tech. You know, my videos are going to help a lot, and I really plan to help you guys because I'm here to relate with you, like I said, like I always say. So thanks for watching, guys. I hope you guys have a beautiful day, because you're all amazing people, and stay tuned for my next video. Peace.